Today, we're diving into one of the most game-changing technologies in all of robotics. We're asking, how do we give machines the incredible gift of sight? We're talking about computer vision, and believe me, it is changing absolutely everything. To really get why vision is so important, let's just start with a really simple question. What can a robot actually do if it's completely in the dark? Seriously, picture it. It can't see a thing. All it has is a rigid set of instructions to follow, step by painful step. And that really brings us to a tale of two very different robots. On one side, you've got the robot running on those pre-programmed instructions. It's rigid, it's super limited, and it's totally unaware of anything that changes around it. But on the other side, a robot with visual perception, well, now it's adaptive, it's intelligent, and it's actually aware. It's not just blindly following a script anymore, it's reacting to the real world as it is right now. So how do we get from that blind machine to the one that's truly aware? Well, we give it the gift of sight. This, right here, is the key. This is what unlocks a robot's true potential and transforms it from just a simple tool into something so much more. And that key, well, it has a name: computer vision. And what it is the field that lets machines see, and this is the important part, to interpret what they're seeing. See, the goal isn't just to slap a camera on a robot and give it a video feed. The real goal is to give it understanding. So how does this all work under the hood? It's actually a pretty straightforward three-step process. First, you capture. The cameras are the robot's eyes, just grabbing all that visual data. Second, you process. Powerful algorithms act like the brain, making sense of all those pixels. And finally, number 3, you understand. The robot actually extracts meaningful information that it can then act on. It's this incredible dance between hardware and software, all working together perfectly. Okay, so we know what it is. Now we get to the fun part. What can robots actually do with this sight? Let's start with how computer vision helps them understand and move around in the physical world. The first and maybe the most fundamental application is just simple object recognition. I mean, before a robot can do anything useful, it has to know what it's looking at, right? This basic skill is the foundation for pretty much every other physical task. And this shows you just how incredibly versatile that one skill is. In a factory, it's sorting tiny parts on a conveyor belt faster and more accurately than any human ever could. For mobility, think about a self-driving car. It has to use this to spot pedestrians and read traffic signs. That's a matter of life and death. And even in our own homes, it could be a robot identifying a coffee mug, knowing exactly how to pick it up without crushing it. So you've got 3 totally different worlds, all running on the exact same core ability. But just seeing objects is only half the battle. A robot also needs to figure out how to move around them. And that brings us to the next huge application: navigation and mapping. This is how robots build a kind of mental map of their surroundings, so they can find their way through really complex, constantly changing environments. And just think about the incredible things this makes possible. You've got robots in massive warehouses that can zip around crowded aisles without ever bumping into each other. You have drones that can fly themselves through a dense forest, dodging every single tree. And then, literally on another planet, you have a Mars rover analyzing the terrain to plot a safe path. This is real autonomy in action, and it's amazing. All right, so robots can handle the physical world. They can see objects, they can navigate spaces, but what about the most complicated, unpredictable thing in any environment? Us, people. So now, let's look at how computer vision helps robots interact with the human world, turning them from simple tools into actual collaborators. And the key to all of this is human-robot interaction. Using computer vision, a robot can actually start to understand us. It can see our faces, it can read our gestures, maybe even get a sense of our emotions. And that allows for a much more natural, much more intuitive way for us to work with them. This is where it gets really personal. A robot can learn to recognize your specific face. It can understand what you mean when you point at something. And some advanced systems can even analyze facial expressions to get a read on human emotions. This ability to read the room, so to speak, is what's going to make these machines so much more effective and, frankly, more approachable as partners. Okay, so moving from interaction to inspection, our final application really plays to the strengths of computer vision's incredible precision. We're talking about quality control and monitoring. This is all about using a robot's tireless, superhuman eyes to make sure things are done to the highest possible standard. And the impact here is just
It's huge, especially in fields where mistakes are not an option. Look at manufacturing. Vision systems can spot tiny defects that a human eye would just gloss over. In agriculture, they can fly over fields and monitor crop health, catching diseases before they can spread. And in medicine, wow, computer vision can guide a surgeon's tools with a level of precision that is literally superhuman. In every single one of these cases, it's about boosting reliability where it matters the most.
So, when you pull all of this together, object recognition, navigation, human interaction, quality control, what does it all add up to? Well, it signals this fundamental shift in how we relate to machines. We're moving away from seeing them as just tools and starting to see them as autonomous partners. You know, there's a quote from our source material that it nails it. It says that computer vision transforms them from simple tools into autonomous partners, capable of working safely and effectively. That word right there, partners, that's the whole game changer. So really, when it all comes down to it, this is what you need to remember. Computer vision isn't just some cool extra feature. It is the core, foundational technology that brings robots out of the dark and allows them to be truly aware of and responsive to this incredibly complicated world that we all share. And that leaves us with one last thing to think about. We've spent all this time talking about how vision changes what robots can do in our world. But here's the question. If robots can truly see and understand our world, how is that ultimately going to change theirs? Thanks so much for joining me for this explainer.